and corresponding sides are proportional. So similar polygons are polygons having corresponding angles congruent. But now what's happening is you have corresponding sides that are proportional. What does proportional mean? We've been doing a whole bunch of proportional stuff in sections 1 and sections 2. So what's proportional? Yeah, so a proportion, right? So you have some fraction equal to some fraction, right? So if you're proportional, you should be able to create a proportion itself. Okay? So similar polygons are going to have congruent angles still, but the corresponding angles are going to be proportional. Think about a photocopy machine. Have you guys used a photocopy machine in your life? So what you can do on a photocopy machine is you can take an image of something and you can blow it up by 200%. So then you would put it down, it would photocopy it, and then it would come out and it would be much bigger. Okay? The angles of that triangle, if it was a triangle, would not change, but the sides definitely got larger. Okay? Just projecting something. This image is a lot larger than the image that's on my computer screen, right? Or up here on my iPad. They're similar because they look the same, but are they the same size? No. This one's definitely a lot larger of an image. So they are proportional to each other. I don't know what the proportion would be, but I'm sure you figured it out if we measured it and did the math. Okay, so when you have similar polygons, what you're going to end up having is what's called a scale factor. So the scale factor is the number that describes the change from an original figure to another figure. And to make our lives easier, we're going to use the letter K to represent our scale factor. If your K is larger than 0, would your new image be larger or smaller than the original? Yes. So the new image would be larger. If your K was in between, actually I guess if it was larger than 0, that doesn't make sense. It should be larger than 1. Change that 0 to a 1. Because if my scale factor was 1, would anything change? If you just multiply all the sides by 1, they'd be the same, right? If my scale factor is between 0 and 1, meaning that it's some type of fraction, then my new image would be smaller. Okay. So if you had a scale factor of 2, what's happening from the original to the new? It's being doubled. If you had a scale factor of 3, what's happening from the original to the new? It's being tripled by size, right? If my scale factor was 1/2, what's happening from my original to my new one? It's being cut in half, right? So it's going to be smaller by half. If my scale factor was 1/3, then my original image is going to be cut by 1/3, and it'll be smaller by 1/3. Okay? All right, so we've got scale factor, and then you're also going to be asked to write similarity statements. Similarity statement is very similar to our congruent statement, but now instead of the equal sign with the squiggly for congruence, we just use the squiggle for similarity. So whenever you see this squiggle without the equal sign below it, that means the word similar. So we were using the equal sign with the squiggle above for congruence, Just the squiggle is representing our similar. Okay? All right, so first example, we need to decide, are my polygons shown here similar? If so, write a similarity statement. Okay, so I've got two rectangles. The first thing we need to check is, do I have congruent angles? Yes, because they all happen to be what degree? 90. Okay, so I've got congruent triangles, yes. So that's good. Now I need to check for proportional sides. Okay, now what's nice is this is a rectangle, so my length and width are the same for both the lengths and both the widths. So I really only need to check two of my sides, comparing them. So let's start here with the smaller one first. What's my largest side out of 6 and 8? 8. So I'm going to make 8 be proportional to the largest side in my larger rectangle, which happens to be which number? 14. Good. So now I'm going to need a calculator, and I'm going to do some division. 8 divided by 14 is the decimal, 0.571 with some numbers after that. Now let's do the same thing for the small sides. So my smallest side on the left is 6. My smallest side on the right is 10.5. Calculator work. 6 divided by 10.5 gets me 0.571, which is the same number. So, are my sides proportional? Yes. So my sides have the same proportion, the same ratio, which means that they are proportional. So this is a yes, Connor and Jackson. So that means, are your polygons similar? Yes, they are. So now let's write a similarity statement. So I'm going to say polygon ABDC is similar to, what's going to match up with A? K. What matches up with B? M, and then L, and then J. So that would be my final answer. Okay. All right, so let's check the next one. Is everybody okay? All right, so first thing, let's check angles congruent. Do I have all 3 sets of congruent angles? Yes. I've got A matching up with O, I've got C congruent to D, and I've got T congruent to G. Perfect. All right, so now we got to check our proportional sides. All right, so the smallest side on the left is 5. The smallest on the right is 4. So 5 divided by 4 is 1.25. Now let's go to the next largest. So 10 would be compared with what on the other side? 8. So 10 divided by 8 is 1.25. So far, so good. Now let's do the largest. 12 divided by 9.6 is 1.25. So are my sides proportional? Yes. So are they similar? Yes. I don't know my answer. Here we go. Yes, they are similar. So triangle. Did I do this on purpose? Triangle cat. Is that similar to triangle dog? C matches up with. It does. I probably did do that on purpose. So triangle cat is similar to triangle dog. Okay. So, would you be able to do this on your homework? Given 2 polygons, check to see if they're similar. If so, write a similarity statement. The only time we really put a symbol in front of our letters is when it's a triangle. If it's anything larger than a triangle, you just list the letters. So you don't have to put any symbols in there. All right, so next example. here they're telling us that triangle RST is similar to triangle XYZ. So that means all my angles are congruent. That means all my sides are proportional. So for part A, list all pairs of corresponding angles. And we don't even have to look over here. I can just pull that from my similarity statement like I did with my congruent statement. So angle R would be congruent to what? R would match up with X. So angle R and angle X are congruent. Angle S matches up with angle Y. And angle T would be congruent to angle Z. So list all pairs of corresponding angles. There they are. And we're just getting that directly from our congruent statement, or our similarity statement, just like we did with our congruent statement here. So for part B, we want to decide what is the scale factor. Okay, so if we're going from left to right, if it does not say something to something, just assume you're working left to right. So if this is my original, and this one is my new one, should my scale factor be larger than 1 or less than 1? Less than 1 because it's getting smaller, right? If it's larger, that means it should be getting bigger. All right, so now we got to make a fraction out of something. Give me a side length over here. Which one do you like the best? 20? All right, so I heard 20. So now if I put 20 over 12, is that going to get me a number larger or smaller than 1? If my number is larger in the numerator, is that a number larger than 1? Yes. So what I want to do is I want to flip it so that it is 12 over 20. So for your scale factor, you're going to put new over the original. Just like when we did our scale for the homework, we did the model over the actual, right? So the model is the new one over the actual. So the same thing applies here. New over the original. Can I reduce 12 over 20? So taking out 4 gets us 3/5. So my K is equal to 3/5. It would be 3/5 either way. If I did 15 over 25, does that reduce to 3/5? Yeah. If I did 18 over 30, taking out 6 gets me 3 over 5. So it doesn't matter which which ones you pick, you're still going to get the same scale factor. Okay? All right. Let's flip on to the back. So now again, they're giving us similar polygons, but now we have to set up our proportion to solve for x. In your homework for section 6.2, they gave us the proportion and we just had to plug the stuff in, right? But now they're not giving us the proportion. We have to come up with it ourselves and plug the stuff in. So I see x is right here. What side on the other triangle corresponds to x? 20. So let's make that as a fraction. Now we could do 20 over x, or we could do x over 20. Either would work. So if I do 20 over x, can you give me another ratio comparing sides? Well, if I do 20 over x, then I'm going to do 12 over 9. Good. Okay, so make sure if you're working left to right that you go left to right on the other one. Would it have been incorrect to also do 16 over 12? No. No, I could have done that too. Can we solve that proportion? Yeah. Yeah. Do some cross multiplying. So 12x is equal to 180. So that gets us, what? Divide by 12, 15. X is 15. Would it have been incorrect to do, I could have done 12 over 20 is equal to 9 over x. Do I still get the same cross products as I did over there? Yeah, so that's why we went through all those properties on Wednesday, because this would kind of be the changing of the means. All right, questions with that one? All right, let's go to the last one, and there's one more thing I have to add to your notes. So in the diagram, we're told that ABCD is similar to QRST. What's the scale factor going to be? Keep in mind that it is new over the original. Someone give me a ratio. Well, 4 over x would not give me an actual number for a scale factor. 6 over 12, which is 6 over 12 reduces to 1/2. So my scale factor k is 1/2. So if I'm going half each time, you could probably do this without even setting up a proportion. What should x be? It would be 8, right? Well, 12 is going to 6, right? Half of 12 is 6. Half of 10 is 5. Half of 16 is 8. So half of what is 4? 8. If you can't think about it that way, you could set up your proportion. We could do x over 4 is equal to, I don't know, 12 over 6. So then you get 6x is equal to 48, so x is equal to 8. Okay. All right, so the only other thing that's not on your notes, and I don't know why I don't have it in there, you're going to have to be required to do for your quiz and for your homework, is something that's called a statement of proportionality. So if we could just add this at the bottom, you should have some space there. So you are going to be asked to write a statement of proportionality. Just add this to the bottom. Okay, so if I give you a similarity statement, let's just go triangle x, y, z is similar to triangle RST. We already did the one example where we listed the corresponding angles. So angle X would be congruent to angle R, angle Y would be congruent to angle S, Z would be congruent to T. But now we're going to do a statement of proportionality, which means I need to write a proportion. And what is proportional? The sides. So instead of saying XY is congruent to RS, I'm going to say side XY is, well, let's not put all those lines in there, is proportional to RS. And I'm going to set that equal to, what would YZ be over top of? Good, so YZ would go over ST, which would also be equal to XZ would be proportional with RT. Okay, so if you are asked to write a statement of proportionality, you should have a proportion of the sides. Okay? And that is that. So you guys have any questions about similar polygons? All right, so you have the rest